An introduction to functions, understanding the terminology. What is a function? When mathematicians and scientists look at the world around them, they notice that different types of relationships exist between the many items that they see. They try to model these relationships with equations. There are two terms that can be used to describe these different types of relationships. First is the term relation, a short form, of course, for relationship. But some relations can be functions. So what are relations? What are functions? Let's investigate. Relations. Let's define the term variable. A variable is a placeholder or a letter that is used in an equation to represent values that can be put into or get out of the equation. The most common variables you will encounter are x and y, but there can be many, many more. A relation is an identified pattern between two variables that may be represented in the form of ordered pairs, table of values, a graph, or perhaps an equation. A function is a special type of relation in which each value of what we call the independent variable, or the data being put into the equation, normally the first coordinate, corresponds to exactly one value of the dependent variable value, the second coordinate. The dependent variable is the data that's coming out of the equation. A function is a relationship then between two variables. The input, the data going into the equation that's given or known, and the output variable, which is the results coming out of the equation. What is the vertical line test? It's a method for determining whether a relation is a function. If the vertical line drawn intersects the relation at only one point, then the relation is a function. Here is an example. Use the vertical line test to determine whether each relation is a function. Justify your answer. Here is the first graph we want to look at. Is it a function? Draw a vertical line. This line passes through the point x is equal to 1. Since it crosses the graph at only one coordinate, this relation is a function. Here is graph number 2. Is this graph representing a function or not? Draw a vertical line. This line crosses the graph at 2 coordinates. This relation is not a function. A mapping diagram can also be used to visually determine whether a relation is a function. Arrows are used to map the x values onto their corresponding y values. Here is an example. These are my possible x values. Here are my possible y values. The dotted arrow indicates the mapping. What's my conclusion? In the mapping diagram shown on the slide, for every x value, there is only one y value. That means this diagram represents a function. Now, let's look at another example of how to visually represent a relation using a mapping diagram. We are still using the arrows to map the x values onto their corresponding y values. Here are my x values, and here are my y values. Notice I have more y values than x values. 0 is going to map to 0, but also to 1. 1 is going to map to -1 and -2. 4 is going to map to 2 and to -3. 9 maps to 3 and -4. And 16 maps to 4. Is this a function? Our conclusion, since the mapping diagram shows for every x value there is more than one y value, this diagram does not represent a function. What is the domain of a function? The definition of a domain is the set of the first coordinates of the ordered pairs in a relation. What this means is that we take all the x values and join them together in a set, and that is called domain of the function. What is the range of a function? The range is the set of the second coordinates of the ordered pairs in a relation. This means the y values in the function or relation. Now, let's look at an example. Determine the domain and the range of each relation. Use the domain and range to determine if the relation is a function. The set of ordered pairs -3, 4, 5, -6, -2, 7, 5, 3, 6, -8. The solution. If we take the set and we find the domain, -3, -2, 5, and 6. Notice that although we have two 5s, we just need to list it once in the domain. This is a clue whether it is a relation, that's a function, or not. But let's look at the range. The range is the set of -8, -6, 3, 4, and 7. For the analysis, is this a function? Now for the solution. Once again the set. Since the x value 5 has two corresponding y values, y -6 and y equal to 3, this relation is not a function. Here is a table of values that will show us example 2. It's a table that shows the number of children of each age at a sports camp and their corresponding number. What is the domain and the range for this example? Is this relation a function? The domain is the set of all x values, which is in the first column of the table, which is your age. So the domain would be 4, 5, 6, 7, 8, 9, 10. What's the range? Put them in order. 5, 8, 9, 11, 12, 14, 22. This is a function because for each value in the domain, the first column is exactly only one value in the range, the second column. Another concept we want to look at is what's called set notation. Set notation is a format that is used to write the domain and range of a function. The notation is written as the set of x such that x is an element of the real numbers. Read, the set of x such that x is an element of the real numbers. You will use this frequently. What is an asymptote? The asymptote is a line that a curve or graph approaches more and more closely but will never reach. For example, let's graph the equation y equals 1 divided by x plus 3. Here is the graph for that function. This graph has two asymptotes. Let's investigate. The first asymptote is x is equal to negative 3. But why is it an asymptote? First of all, we have to realize that you cannot divide by 0. So if the denominator x plus 3 becomes equal to 0, the function would be undefined. If the value of x was assigned as negative 3, negative 3 plus 3 would be 0, which would make the equation undefined. That is why x equal to negative 3 is an asymptote. X plus 3 cannot equal 0, so x cannot equal negative 3. The graph can never reach negative 3. All other values can be used for the x value of the equation. This vertical line, x equal to negative 3, that the graph can approach but never reach, is called an asymptote. Now, the domain would then be written, the set of x such that x is an element of the real numbers, comma, x cannot equal negative 3. We read this as the set of x such that x is an element of the real numbers and x cannot equal negative 3. Now, for number 2, for the range, there can never be a situation where the result of the division is 0. 1 divided by a non-zero value can never equal 0. This means that this function has an asymptote occurring at the y-axis. The value for this asymptote would be y equal to 0. Written as the set of y such that y is an element of the real numbers, y cannot equal to 0. Here it's shown in the graph. So we have a vertical asymptote and we have a horizontal asymptote. In the next video, you will learn how to determine the domain, the range, and the asymptotes for a variety of functions.